Okay, so who is Hugues Ferreboeuf? He's a graduate of École Polytechnique and Telecom Paris Tech, and he has been in the information technology sector for 20 years or more in senior management positions. He was in government agencies and also in small companies, high growth ventures, what I got to know. And in 2016 he joined the French think tank, the Shift project. I guess he will explain a little bit more about the Shift project. Anyway, he was the head of the Lean ICT project, or how to make the digital transition environmentally friendly. He is also a partner in Virtuous Management, a management consulting boutique in Paris. I welcome you very much, Hugues, and I hope you will have a good talk. Thank you.
Okay, good evening, because it's evening now, so I will try to make the presentation as concise as possible. Many slides, so I will have to go fast on some of them, but hopefully there will still be some room left for questions, so hopefully my presentation will still be understandable. So not losing more time, the title of my presentation might seem a bit provocative. Why we need to redesign internet to fight climate change. But actually, you will see that there is some relevance in that statement. A good part of the things I'm going to share today come from the work we conducted within the Shift project for 2 years. We published a report, the English version, in March last year. So you will be able, if you will, to find much more details on what I'm going to explain on the website, because all the documents are freely available. One more thing, we are proceeding with second phase of the project, and I will mention a few things about that, knowing that the report is not ready at all. It should be published in June or something like that. So I'm first going to talk a little bit about global warming, because I think it's important to have a few key points in mind in order to understand what I'm going to explain later on regarding digital. And one important thing is to realize that actually the carbon issue is first an energy issue. Then I will try to describe the digital energy consumption dynamics. So not only what is the trend, but why we have the trend we have at the moment, and what are the levers to change it upwards or downwards. And then I will come to the conclusion, which is why do we have a design issue, and it's just not a matter of better technology, it's a matter of defining the system we want to use. So global warming. So that's the word that may be ours, or more probably yours, in 60 years or so. And that would correspond to the vision actually we had a few years ago of what the BAU scenario would lead us to. The reason why I'm showing that is just to show you that this BAU scenario would lead to an average temperature increase of 3.5 degrees. But you will see, and you can see on, I don't know if it works, yes. You can see on the map that for some regions of the world, these 3 degrees or so actually can be 9, 10, or even 11 degrees, especially in the northern part of the globe. So just to show you that in terms of climate change, as for many other things actually, it's very dangerous to look only at average figures, but it's very important to look at the distribution of the impacts. The other thing to have in mind is that the consequences of climate change are not at all linear. There will be a big difference between a global warming of 1.5 degrees or 2 degrees. It seems a very small difference, but actually the consequences are radically different. And one way to have that in mind is to see what would be the intensity actually and the frequency of, for instance, extreme weather events, depending on the value of the average temperature increase. You see that at 1 degree, we're still in the yellow phase. At 1.5, we are in the orange phase. At 2, we are in a much more darker phase. So that means that many more parts of the world would be impacted. And that means that the impacts would be much more frequent and much higher in terms of intensity. So that's why in 2015, when the COP21 met in Paris, the objective was written as being, let's try to keep the average temperature increase as close as possible to 1.5 actually. Because the difference between 1.5 and 2 degrees is going to be huge for some countries. Some countries will just disappear if we reach 2 degrees. Some islands especially. Third thing to have in mind is that the global warming issue is actually a stock issue. Why? Because actually the amount of temperature increase that's going to happen is directly proportional to the stock of carbon which is in the atmosphere. And this carbon, when it is in the atmosphere, is going to stay for a few hundred years. Okay? So that means that whatever actually we do tomorrow, even if we manage by magic to bring our annual emission gap, our annual emission to 0, we still have to deal with the existing stock. And the existing stock is such that actually the temperature increase will be at least 1.5. So the issue now is to understand what we can do in order to avoid to go much beyond 1.5. And as I said just 2 slides before, it will be very impactful for some parts of the world. So I don't have time to explain in details, but I will be able to answer some questions if you have that at the end. So the carbon stock, what is happening is actually the carbon stock is too high compared to what it has been during a few 100,000 years. So this chart actually gives you the CO2 concentration in the atmosphere in ppm, and as you can see, for a few 100,000 years, it stayed, let's say, between 200 and 300. And at the very And so very recently, it has jumped now to more to 400. And actually, it's quite recent because all these things happened, let's say, starting in the 1950s. So we have to be aware that the issue we face for the rest of the century do not come from hundreds or thousands of years of history. They really come from what we have been doing since the 1950s. One thing maybe, there have always been, of course, CO2 emissions, but most of them during these few 100,000 years were due to what the scientists called land use change, which means basically deforestation. The more trees you have, the more they can absorb CO2, and when you cut trees and transfer that into lands that you're going to cultivate, it's going to cause some emissions. But as you have seen, that was okay, let's say, until the 1950s. And what has been happening is that since the 1950s, what causes mainly the emissions is the use of fossil energy. So it's a good bridge to the former presentation. So until now, I was talking about the stock of carbon. Now we can have a look at the flow. And as you can see, it's not a good picture because not only the flow is positive, which means that the stock is increasing, but this flow itself is increasing. So in 2019, we should have emitted around 37 gigatons of CO2 in the atmosphere. And that's, about twice as much as 30 years ago. One thing which is important for the rest of the presentation, basically we could say that there have been two digital transitions until now. One more or less in the 1990s up to 2000, where it was really enterprises getting computers and this type of things, and the upcoming of internet. And since 2010, the second phase of digital transition where actually, which is more or less, let's say, the smartphone era. But as you can see, these two digital transitions have not changed the general trend, unfortunately. One thing also which is important is that, of course, the emissions come mainly from burning, let's say, fossil energy. But we have to be aware that even if a lot of emissions actually happen in China, for instance, as you can see, that's the biggest emitter. Actually, a part of these emissions are directly related to the products we are buying from China. Okay, so that's the difference between the solid line and the dotted line. As you can see, the carbon footprint of Europe is higher by at least, let's say, 1 gigaton, considering the imports of products and the embodied energy and embodied carbon footprint that is in the products that we are buying. So, in other words, if we were not buying so many products, the footprint of China would be a bit slower. Okay. So in other words, the smartphones we are using and we think are perfectly clean actually are mainly built in Asia using Chinese coal. Another aspect of the climate change issue, which makes it particularly difficult to solve, is the fact that, again, it doesn't make sense to say things on an average level. On the left-hand side, you have a graph which shows the annual emissions of CO2 per capita in different regions. And as you can see there, it's not anymore China which is on top, that's the US. Okay? And if you compare the emissions per capita in the US and in India, you see there is a ratio of 1 to 8. Okay? So we have a global problem, which is climate change, but the reasons behind are not at all evenly split among countries. And so, if we want to reach annual emissions equal to 0, you can see that the task is going to be much more difficult, actually, in the US than in India. On the right-hand side, it shows you how the global emissions are split across the different shares of population. And as you can see, 20% of the population here represents actually 50% of the emissions. And of course, this 20% basically is based here and here and a little bit here. So this chart comes from a report from United Nations, and it shows you different things. One, what would happen if nothing changes? As you can see, the emissions, and here it's not anymore only CO2, but it's all GHG, so that's why the numbers are a bit higher than the ones you saw before. But you see it's going there. That's the trajectories that were agreed during COP21, and unfortunately you can see that they are still going up. And actually here you see what would be needed if we want to keep temperature increase below 2 degrees or below 1.5. Okay? And as you can see, in both cases, the change is brutal. But what is happening at the moment is that actually not only the countries are not in line with the targets they agreed upon 4 years ago, but on top of that, the targets they agreed upon on top of that are far from enough in order to bring us to what we need to be. Okay? So just to show you that the picture is not very nice, which I think you knew, but I hope now you understand a bit better why. So this chart is a bit easier to read, and it's important because when we are going to assess what is going on in a given industry sector, it's not enough to say, well, the emissions are going up or going down. It's not anymore enough. What is the benchmark is, is the trend of annual emissions in line with what the global trend needs to be. Okay? And the global trend is actually these ones. So if we choose to start cutting down the annual emissions, let's say this year, because we're in 2020, we actually need to decrease them by 5% a year, at least, if we want to have a chance to be significantly lower than 2 degrees. Okay, that's the blue line. But if we wait 4, 5, or 6 years more, it won't be 5%, it will be 10%. As you can see, the feasibility in both cases is very different. A number of you work in this industry. 5% a year is obviously difficult on a rolling basis in the long term. 10% is impossible. So there is one figure, if any, which has to be remembered, is that the challenge for the next 10 years is to divide by 2 the CO2 annual emissions. So we have to go basically from 40-something to 20-something here. So why is actually climate change an energy issue? There are different gases which are part of GHG and which cause global warming. And as you can see, CO2, but also CH4, N2O, and a few other gases. But as you can see, in terms of volume, CO2 is the most important. And not only in volume it's the most important, but it is the one which is going to stay in the atmosphere the longest. Okay? CH4 instantaneously has much more impact than CO2, but CH4 is disappearing in a few years. As I said, CO2 is disappearing in a few hundred years. Okay? So the impact on the stock is quite different. So, as I said in the beginning, use of fossil energy is actually the main source of CO2 emission at the moment. And here you can see how these fossil CO2 emissions are split across industry sectors. As you can see, the power industry is the one which is the biggest emitter. Because at the moment in the world, most of the electricity is still coming out of coal. The second sector is industries. And the third sector is transportation. Okay. But unfortunately, none of these sectors has been able yet to reduce its annual CO2 emissions. So the first year when the world, in terms of international arena, became serious about climate change was in Kyoto more than 20 years ago. And as you can see, even though we have been serious, basically each sector has continued to increase its gas emissions. And actually, it's the case of digital as of any other sector. So, as I'm talking about carbon and energy, The thing to understand is that not only most of the CO2 emissions come from the use of fossil energy, okay? So that's one thing. So the answer would be, okay, let's switch rapidly to renewable energy, decarbonized energy. Yes, but unfortunately, the constraint we have to face is what we can do and what we must do in the next 10 years. And according to the International Energy Agency, we need actually not only to change the energy mix, but we need to stabilize and even decrease the global energy consumption if we want to be able to limit the CO2 emissions as much as they should. Okay? So that's the other constraint that is rarely, let's say, mentioned in the media. But this one is very important because that means that basically the energy is going to become scarce. And that means that when assessing whether a sector is behaving in the right way regarding climate change, not only you have to look at how its carbon emissions are evolving, but also at how its energy consumption is evolving. Because what is happening is actually our industrial capacity to produce the equipment that then can produce renewable energy is going to be limited in the next 10 years. So if a sector increases too much its energy consumption, and even if it manages to use mainly renewable energy, it is actually going to preempt this capacity from the other sectors. So he is going to solve his local problem, but it's not going to help solving the global problem. Okay, so after these refreshing slides, I know, I'm going to talk about digital and why is the topic of relationship between digital and the environment becoming an issue. So that's the evolution of the share of digital in terms of GHG emissions between 2013 until now and probably until 2025. As you can see, a few years ago, digital was representing about 2.5% of the global worldwide GHG emissions. That was about the same as the airline industry. And you may still read in some papers that digital can be compared to airline industry. Yes, but that was before. Now it's about 50% higher than the airline industry in 2019. And what is really an issue, because you could say, okay, but it's 4%. If we look at transportation, it might be 20%. If we look at power industry, it's 35%. So let's concentrate on power and transportation. Yes, we have to do things there. But what is more worrying is actually the trend. And at the moment, the carbon footprint of digital is increasing at about 8% a year. So, as you may remember, each sector should be reducing its carbon footprint by 5% starting next year. Okay? So, switching from 1 or 2% to minus 5% is already difficult. Switching from plus 8% to minus 5% is very challenging, let's say. So that was the carbon aspect. If you look at energy, well, it's simple. The energy consumption coming from digital is exploding. basically between 2013 and 2023, it will have more than doubled. And if we continue on a BAU basis, that means as we have been doing things in the past 10 years, we might actually triple the energy consumption between 2014 and 2025, okay? So there are different colors, and I don't have time to explain, but it comes from a work we did with different scenarios, with sensitivity analysis and so on. And the thing to understand is that we need to have a tipping point somewhere this year or next year if we want to avoid worsening the phenomenon. Okay. Yeah, one very important thing, because it's generally not natural. Energy consumption comes not only from the phase where we are using the equipment, which consume electricity, but also from the phase where we build these equipments. And there is a lot of energy needed to build these equipments, even if they are small. This thing, actually, 90% of the energy used during its lifespan is going to come from the production phase. So basically, the important thing regarding a smartphone is whether you are going to buy it or not. Then you might use it 1 hour a day or 20 hours a day. It's not going to make a big difference for its direct impact, of course. Now, why I'm saying that, actually, if we look at how the energy consumption is split, about 45% of the energy consumption comes from the production phase. Sorry, that's here. And it comes basically from the production phase of appliances, terminals, so that's smartphones, PCs, but also television sets, and a lot of other digital devices, and there are new things every week, almost. In the use phase, as you can see, it's rather evenly split across three categories. One, the direct electricity consumption coming from terminals, and a big part of that comes actually from the TV sets. Then the networks, which we do not see, but which use actually quite a lot of power. And then the data centers that are regularly now pointed out in the media. They are quite important, but they are 1/6 of the problem. So why do we have this trend? There are different reasons. One is that basically what I would call the digital volumes are increasing very, very, very fast. To give you an idea, here you can see the growth rate of the internet traffic, so it's about 27% a year. That's huge. And if you look at what represents today almost 80% of the traffic, it is video. And video is increasing at 33% a year. So the explosion of this traffic is basically, at the moment, coming from the explosion of video usages. If you look at what is happening in the data center traffic, the growth is even higher. Not only in terms of the traffic which is exchanged within the data center, and which is a good representation actually of the workload in the data center. But also, if you look at the data which is stored in the data center, there the growth rate is even higher. It's 36% a year. And when you talk to companies, a lot of them will tell you that they have to increase their storage capacity by 50% a year at the moment. Okay. And of course, the more volumes you have, the more equipment you must have. Okay? Of course, each year, the equipments are becoming more effective. With the same category of equipment, you would be able to do more. But what has been happening in the past 10 years is that the increase of the volumes is too high compared to the technical progress we are able to realize at the equipment level, at the system level, or even at the architecture level. So that was for the traffic, which is the main driver of the energy consumption in the networks and the data centers. Now, regarding the devices, which are 60% of the problem, here you have different things. You have the annual sales of digital devices between 2010 and 2030. As you can see, we were able to produce and sell about 1 billion devices in 2010. That was already a lot. At the moment, we are around 4 billion. And out of these 4 billion, there are about 1.5 billion smartphones every year. And if we believe the analysts and the consultants, we could be in a situation where we would produce close to 10 billion digital devices in 10 years from now. Okay? And that would have, as a result, an impact on the installed bases of connected devices, which would switch from 15 billion today. That means that we have about 7 billion people on the earth. There are already 2 digital devices per person, including the babies and including the 50% of the population which doesn't have access to internet. So, and we could be in a situation where we would have about 50 billion devices in 10 years and more and close to 6 devices per person. Okay? So, as you can see, it has been going fast, and it is not going to be much slower. One more thing to have in mind, until now, the digital devices that we built were really designed, actually, to communicate and to have a human interface. The next source of growth, as seen from the equipment vendors, is the Internet of Things. In the Internet of Things, the purpose of the equipment is not to communicate with us, but is to communicate with other things. So the potential is almost unlimited. And as you can see, it should be the big part of the growth in the next 10 years. And what is called automation here in orange is actually IoT, and 75% of this automation is going to be more or less related to things that we would find at home. And that could go from the connected oven, to the connected fridge, to the connected mirror, to the connected toothbrush, to the connected bed, you can connect anything, okay? And you can even have, I saw a demonstration, you can even have a situation where you are 2 meters from your oven and you will ask Google to switch the oven on in your place because it's going to be much more convenient, as they say. So just to show you that, and the main rationale of coming up with these new devices is not actually to optimize things, but it's to bring more comfort, okay? So in other words, the problem is not the devices that we would put, for instance, in the power industry to build smart grids. In terms of volume, that would be very little compared to all these things. So the problems we have is how much more comfort do we want to have, given the fact that each percentage of additional comfort is going to be very costly, actually, in terms of energy. And so this is another refreshing slide. We have to be aware that not only digital is using energy, but digital is using a lot of metals. And in order to be able to use these metals, you first have to find them, and you have to dig in the ground, and that's called mining. And mining is causing a lot of pollution. So now you do all these things in order to build a smartphone that people, at least in France, are going to use for 18 months. And after these 18 months, they will not go into a formal recycling circuit. 85% of the electronic devices in the world actually do not get processed in a way that will avoid land pollution. Most of them are going to end up in dumps like that, especially in Africa and in Latin America. And yeah, I didn't put that, but it's part of the hidden face of digital, because all these things do not happen in Germany or in France or in Switzerland or in Europe. They're happening here in Africa, in China, and a little bit in Latin America, and here in Southeast Asia, Africa, and a little bit of Latin America. So why am I saying that everything I explained and the fact that the carbon footprint of digital is going up much too fast, why is it a design issue? Okay, to that we have to look at things in a way that economists used to do, and look at the supply and the demand. And actually, at the moment, digitization is a new engine of the consumerist culture. In developed countries, okay, once you have a car, 2 cars, doesn't really make sense to have 3 cars or 4 cars or 5 cars, okay? But once you have a digital device, you can have another one, and another one, and another one, and another one, and so on, and so on, and so on. So, what is happening is that on the demand side, we have an appetite for these things. Okay, so we are keen actually to buy new digital gadgets when we are presented with. That's on the demand side, and on the supply side, the current business model of the vendors is currently product-centric. That means the way they make money is by producing and selling every year more products than the year before, okay? And once they have built and sold the product, it's not anymore in the value chain. So part of the problem is there. If we want, I didn't talk about circular economy, but it has to do with that. If we want to be in a situation where the different parties involved have an interest to do things which are good for the environment, we have to go to different business models. Business model where, for instance, a company not only is going to sell the product, but it's going actually to sell a service, which is going to be the use of a product and the ability to take back the product when you don't want it after a certain amount of time, and the obligation to recycle it after it has been used. Okay? So it's a fundamental switch in the business models, and if it does not happen, there is no reason that the curves I showed you a few minutes ago do not become the truth. And there's the same thing in terms not anymore of digital products, but in terms of digital services. At the moment, most of the traffic on the networks are generated by the GAFAMs, the platforms. The GAFAMs in the Western world and the BATX in China. And actually, the business model of the GAFAM is based on the ability to monetize audience. That means actually you have the impression that you are accessing the services for free. Okay? It's only an impression, because when you are accessing their platform and you stay on the platform knows who you are, what you do, and so on and so on. And the longer you stay, actually, the more audience you build for them. And then they are going to sell the access to the audience to other companies. That's called advertising. So actually, the business model of this platform is such that they have an interest and they have even an obligation that the volumes are increasing more and more, and that in order actually to augment their attractiveness, a few years ago, they found out that video was a good way. And now, instead of accessing information through text, more and more, you are accessing the information you're looking for through videos, even when you don't want to, by the way. But through videos, and not only there is this switch to videos, but there is a kind of a race to the quality of the video. In a few years, we switch from standard definition to high definition, to ultra high definition, to 4K, then to 8K, and guess what? We'll have 16K in a few years. Okay? It's important because when you switch from one format to the next one, actually to transmit the same amount, the same message, the same information, you're going to use 3 times more data. Okay? And the paradox is that not only we are viewing more and more videos, but we are viewing more and more these videos on our smartphones. And at the moment, I never met anybody who is able to make the difference between a 4K video on a smartphone and a standard video, because it would have it would probably be non-human. So not only it is a volume inflation, but it does not really create additional value from the user perspective. So that's one thing. The other thing to have in mind is that you could say, okay, but the volume is increasing, but we just have to work hard with new technology so that to do the same thing, we use less energy and it costs less, and we are becoming more efficient. Well, the problem is that there is something called the rebound effect. Again, don't have time to go in depth, but the rebound effect is the fact that each time you increase the efficiency of a production or a consumption process, you are going actually to induce additional demand compared to the previous state. And in a number of cases, and I would say in most cases, the additional demand will be so high that it will do more than compensate the increase of efficiency. Okay? And that's exactly what has been happening with digital in the past 10 years. So you will, when you speak with vendors, they will tell you, oh, but we have increased a lot the efficiency of our products and so on. And that's true. The problem is that the more they increase the efficiency, and the more we use and generate volumes. Okay. I'll put some figures to show you that when you increase the efficiency by 15% a year and when you increase the volume by 30%, unfortunately, the net result is an increase of 10%, and that's mathematics. So, the other thing to keep in mind, to make it even brighter, is that the situation actually could be worse in the next 10 years than in the past 10 years. Why? Because it's true that we've been able to realize a lot of progress in terms of energy efficiency. The Moore law, the Coumet laws, and so on and so on. You know all of this. But the problem is that at the moment we know that we are reaching the limits of existing technologies. Okay? And one good example, technologies or designs. Good example is a data center. A way to measure the performance of a data center is the PUE, which measures the additional energy which is being used in the data center, not to make the IT work, but to make the environment work so that the IT keeps working. And basically air conditioning and so on. PUE, by definition, cannot be lower than 1. Okay? We made a lot of progress, and basically in 10 years we went from 2 to 1.5. It's much more difficult to go from 1.5 to 1.2. And anyhow, it will never be possible to go below 1. Okay? So that's one aspect. So there is a lot of reasons to believe that the energy efficiency gains are going to slow down. Okay? So if we keep with the same trend in terms of volume, we won't be increasing the energy consumption by 9% a year, but we will be increasing it by 15% a year. Okay. So, in other words, we should not bet on the fact that there's going to be, by magic, some new technologies that is going to solve our problem in the next 10 years. In 20 or 40 years, maybe. But it's not the problem. The problem is to divide by 2 the annual emissions in the next 10 years. And for that, and for digital, we cannot count only on technology. So we have to find a way to reduce the volumes. And actually, it should not be so hard. Because, as I said, 80% of the volume today on the networks are videos, and 80% of this video is actually online video, which is more or less watching a movie in a streaming mode on your smartphone. Okay? So there will be a trade-off to define. How much more movies do we want to watch every day? Or could we be satisfied with a bit less movies and have a chance to stay below 2 degrees? But that's exactly the problem. And by the way, it's a problem with digital, it's a problem in many other sectors, but it's very, let's say, it's very clear in digital. And when I'm saying that, I'm not saying that we should stop using digital, or we should stop using more digital. No. We could still allow to continue the digital transition, but we just have to be a bit more selective in the usages we want to make of digital. Okay? So it's easier to say than to do. But on the other hand, if you look at the industry, it would be much easier for them to find new business models and still be in a growth mode with a traffic that would increase by 17% a year. Okay, twice as less as 30%, but still. It would be much easier than for the airline industry, which is going to realize in a few years that they will have to cut the traffic in order to be in line with the carbon emission reductions. And that will mean, of course, a lot of bankruptcies and a lot of difficulties on the economic side. So I think digital is interesting because it's kind of paroxystic in terms of showing the impact of our behaviors on the climate change. And on the other hand, if we think a little bit about what we do, it will not be so difficult to change our habits. So of course, we shouldn't have too many of these things. That was Las Vegas CES last year. I don't have yet the pictures of this year because it's ending today, but I'm sure they will have found new things, new exciting things, such as the connected hairbrush. Here. So what is the way forward? Clearly, it's very difficult for a given person or even a given company or even a given digital supplier to change the way it works and it acts if the whole system is not changing at the same time. Okay? So we have a systemic issue to solve, and we have to find ways to help the different parties, the consumers, the enterprises, the states, the suppliers, to move in the same direction. So to do that, and that's what we try to do at our level, we first have to inform, because I guess that a lot of the things I said today you didn't know. We have to inform, and probably creating awareness is more than 50% of the solution of the problem. We have to inform also enterprises and show them that it is possible to define what I call an augmented digital transition. And it has started actually, I don't know in Germany, but in France I know now a lot of large companies which have become aware of the carbon footprint of the IT systems and have become aware also that it's not only a matter of better operations or better technology, but it's also first a matter of corporate policy. And then we have to help, let's say, public authorities to come up with the right messages and sometimes the right regulatory framework to help the different actors move in the right direction. And I think you mentioned a few things coming from the new European Commission, and I can confirm that this subject is actually on the agenda. And it's necessary, let's say, to show to the digital sector which way Europe wants to take if we want the different players to move in a coherent manner. So that's what we're doing at the moment in the phase 2 of our project. Trying to provide recommendations for public policies, studying what are the drivers of the demand, working with a few large enterprises to, for instance, understand how we can integrate the environmental dimension into the enterprise architecture formal frameworks. I don't know if some of you know Archimate, TOGAF, and so on. We also are working on something which I think is very interesting, which is there is a lot of projects, a lot of initiatives which are called SMART. Smart mobility, smart cities, smart home, and so on and so on. And at the moment, in France, the local authorities, regions, and so on, they receive a lot of visits by a lot of parties telling them, oh, you should do that, you should do this, because if you do a smart thing, of course, your city or your region is going to become much smarter and much more efficient. And actually what we're trying to do is to show that yes, it can work, but there is a number of conditions which have to be existing in order for a smart initiative to have a chance to be smart from the environmental standpoint. And as a counterexample would be the smart light at home. Smart light, you know, that's these new light bulbs which have a digital module in them, and this module is continuously on and is able to detect whether there is somebody in the room or not. And depending on whether there is somebody or not, it's going to switch off or on the light. The problem is that if you look at the embodied energy needed to produce the component, the digital component, and if you take into account the fact that this digital part is actually going to be always on, you can see that it doesn't make sense at all for a room at home. It can make sense in a public environment with a lot of different lights and so on, and a lot of traffic in the room, but not at all. So just to show that the same thing called smart effectively be smart in some environments and won't ever be smart in other environments. Okay, So trying to inject some rationality in this type of decisions. And last but not least, 2020 is a year of 5G in Europe. You have to know that a 5G equipment is using between 2 and 3 times more energy than a 4G equipment. Of course, it's going to be able to process much, much, much more traffic, but it will always be consuming 2 or 3 times more energy. And as I said before, the carbon issue is first an energy issue. Okay, and I will stop there because I've been long enough.
Thank you very much, Hugues, for your excellent talk. And actually, I'm noticing something. He's been overtime in many days at the Alumni Day, but usually at around 6:45 or so, people tend to leave. Nobody left today, I think.
Ooh.
So it's really...
I'm sorry.
It's really great. So apparently everybody was really listening. Still, are there any questions? I'm sure there are.
You spoke about obsolescence of devices and the emissions during the production phase, for example, of your smartphone. So I jumped to the conclusion that if we had a tax on importing these devices from China, then something might happen. So why are you not suggesting this? Are there any blocking factors to such a tax? Apart from the fact that maybe these devices would become 10 times as expensive as they are today.
No, I didn't say we are not recommending that. Didn't cover everything we do. But it's one of the things which are contemplated at the European Commission level. I think with the, I don't know if you're aware, France tried to impose a tax on the GAFA. It's been quite difficult to do it on the national level. So if such tax should exist, it probably has to be on a European level. And using the weight of the European market could be a quite effective measure. And this type of tax is something that is going to be discussed.
One more question over there.
You said that video consumes a lot of energy, but I noticed at work that instead to go somewhere by car, people just talk by video chat. Can we say that in some cases this digital energy that we get home is because in some other area we have less, we demand less energy because of that.
Yeah, it's a good question. There are actually no answer to this question. Just 2 comments. One, in the past, let's say 30, 40 years, we've been using more and more digital things, and we've been using phones and emails, video conference, and so on and so on. Unfortunately, it doesn't mean that we have used less transportation. The airline traffic has continued to grow exactly at the same pace as before. Okay, that's one thing. Second thing is, at the moment, when I said that video is an issue, I'm not talking so much about video conference. Video conference is maybe 1 or 2% of the global traffic. So that's why I was stressing on the importance of online videos, which is really watching movies in the streaming mode. And there, It doesn't mean that while you are, when you are watching a movie on a smartphone, a streaming mode, you may not go to the cinema, but it's not going to save a lot.
One more question.
How does streaming a video compare to playing an online video game in regards to code? You know that.
Well, there's not going to be much difference. The problem with online gaming is that not only you have one person using video, but often you will have many people watching the same video, so it's going to stimulate the traffic even more. And especially when online gaming is going to switch to 4K, it's going to be 3 times more. And the next step will be to switch to virtual reality, where you will be able to feel you are in the middle of the game in a 3D vision, and there it will use probably 15 times more data.
Any more questions? No? Then just a second. Surprise, surprise. Thank you again.
Thanks a lot.
You're very welcome. You have to carry a lot, I'm sure.
Yeah.